Hello everyone, welcome to the third lecture in IoT. So we in the last lecture we came up to introduction to basic IoT components, and we talked about sensors. Before going into actuators or taking introduction about actuators, let's go back a little bit and see what we have discussed till now, right? So initially we took an introduction to IoT. The Internet of Things describes a network of physical objects, in this case things, that are embedded sensors, processing ability, actuators, software and other technologies for purpose of connecting and exchanging data with other devices, or again things in IoT, other physical objects and systems over the internet. Then we looked at IoT devices that are being or that are in use today. We looked at from cameras, temperature control to lights to motion sensors, contact sensors, plugs, smoke detectors, air purifiers, control centers, controlling units, robot arms, smart fridges, smart locks, vacuums, smart hospital beds, even virtual reality, and small devices like the smart watch to bigger devices like the self-driving cars and weather. Then we took some examples of how IoT devices work in a network, how they make things efficient and how new components can be introduced, what are the things that they can do, why are they much productive and efficient than using legacy systems. We just went through all this. We showed like a set or one of IoT devices which monitors one particular or couple of particular things. In this case, the weather can be applied for different scenarios which are totally different from each other. We check the same thing on set of IoT devices using set of industrial, healthcare and mining locations or scenarios, how each device can work to help each sector, right? We talked about all these things. Then we came into discussing or taking an introduction about the architecture when building a IoT system, and the architecture mainly consists of 4 layers. A total IoT system, it contains 4 layers. First one is the perception layer or devices, sensors. This could be from we talked about sensors, different types of sensors. It could be actuators, which gives different kinds of outputs or takes different kinds of actions. It could be from it could be screens and things like that as well, to communicate with humans or give output to humans in a way that humans would understand. Then we talked about the network layer. Of course, in IoT there are 2 main things. One is a physical device, and that physical device should be connected to the network. So of course the second layer would be the network layer. Then the other 2 layers, which is cloud platform or the service layer. This here of course in the cloud platform layer we talked about generally how cloud platforms are used to create Internet of Things. So resources sharing and building the cloud itself is now a part of the internet. But we talked about this service layer could be done not only through the cloud but through intranet as well. So depending on the scalability of the IoT, that can be changed. But today, in this program, we will be mostly looking at how these devices and sensors are connected to the network, creating an embedded system. But if you are going to build a IoT solution in the future, uh, it won't be mostly about intranet, it would be about internet and using cloud resources as well. So so the service layer, the processing power, the storage power of the cloud can be utilized to have an efficient IoT system. Then the application layer, of course, that would be the layer that will be interacting with the user. This part of it, as you are computer science students, cloud computing and the application layer, or the back end and the front end of application layer with the cloud, is something that you are familiar with. So then we so to make these layers, there should be a set of components that should work together, right? So again, when we talked about IoT, there was it's internet of things. So there should be things and there should be internet, that means there should be network to it. So speaking about the main components of internet of things, the physical things, we talked about sensors, right? So we said sensors are devices that can detect and measure physical or environmental conditions such as temperature, humidity, light, motion, pressure, and sound. These sensors are used to collect data from the environment and send it to an IoT system for processing and analyzing, right? So in our examples, we talked again and again about sensors, right? If you take cameras, it would be an image sensor there. Then in this, there would be a temperature sensor, right? If you take other motion sensor, it would be IR or some kind of a motion sensor that would be there. Contact sensor, it would be mostly magnetic sensor, which would see the contact and the disconnect of these devices. Smoke sensors would have, of course, temperature sensors and sensors to detect smoke, even particles which are needed. Then again, we talked about the fridge. Again, temperature sensors would be there, maybe to check whether food has gone bad. There would be several sensors to detect what is in the air. There would be moisture sensors inside these fridges to see if there is unnecessary moisture in the fridge itself. Then if you take a vacuum or Roomba, then there will be proximity sensors, again image sensors or capacitance to see the fingerprint, so on and so on. We talked about these sensors. So it's so one of the other most let's go to big examples. Pressure sensors would be there. In a autonomous driving vehicle, every sensor that you can think of would be they are doing some kind of a thing. In weather, of course, there would be light, wind, temperature, humidity, so on and so on. Sensors would be there. We talked about it, and we talked about applications of them as well. Then let's look at actuators, right? Actuators are devices that can use physical actions based on commands received from an IoT system, right? So that what does this mean? Actuators are devices that can perform physical actions based on commands received from an IoT system. Here in the sensors, we talked about sensors can detect, measure physical environmental conditions, right, such as temperatures, those things. And these sensors used to collect data and send it to a IoT system, where they will be processed and analyzed. Then the IoT system would give an output or a feedback to, so these are doing mostly input to the IoT system. Actuators, right, will get a output, right, commands received from an IoT system, right. This is data is given in, it will be analyzed, processed, and commands will be given out by the IoT system for devices to make physical actions, perform physical actions, right. That is one of the main points that you should remember. So examples of actuators include motors, pumps, valves, switches, and relays. These actuators are used to control physical devices or systems in response to data collected by IoT sensors. So that is what we were talking about before, right. It is simple. Basically, actuators include but not limited to motors, pumps, valves, switches, and relays, right. So they are physical objects, hardware components that do physical action, taking command from an IoT system. The IoT system gives those commands in respect to the data which is collected from the sensors. Let's look at a quick example from above, right. We will take the Roomba vacuum. This will have a proximity sensor, right. We will talk about different proximity sensors in the next part of the lecture, but for now let's say this has a proximity sensor. It will detect when it's moving forward. It will move forward. That means if the command is already there to move forward, means the proximity sensor hasn't detected anything in front of it, so there are no barriers to overcome. It can just move forward. That means those data will be passed into the IoT embedded system inside this Roomba. It will be processed, and the commands will be given to the motor to move forward. The motor will spin up and the wheels will allow it to move forward. And let's say this Roomba came near a wall. The proximity sensors would detect that there is an object in front of it and it can't move forward in the same particular direction. And that sense, that information collected from the proximity sensor would be given into the processing unit. The data will be given into the processing unit inside this embedded system. Those data will be processed and given into the actuators to either increase or decrease the speed of the motors, right, and make necessary adjustments in the wheels to change the direction of the Roomba and avoid the obstacle, right. That would be a very simple example. So we talked about it in motors, these things. So then a Roomba would mostly work with motors. There are different types of motors that will support the direction of the Roomba. But again, the sensors, the proximity sensor, have to give information whether these motors can either turn the wheels to move forward, or other motors, other actuators to make it turn to another side, right. Again, there are pumps, valves. We will look for examples that pumps and valves can be used. a good example for pumps and valves would be robot arms. So mostly these robot arms, which is a huge actuator by itself, works with mainly by pumps. If you have seen JCB, those excavating units, vehicles, you will see that all the most of the digging parts are controlled by pumps or controlled by liquid pressure, right? So that means that there would be pumps controlling the pressure inside these valves, right, to control the movement of the robot arm itself. And we all know that when using a liquid, to pressurizing a liquid, we can take a far better outcome, a powerful outcome, to maybe to lift a bigger weight, to cut through hardened materials, right, for things like that. So again, this would have sensors. We talked about this having sensors of sensors to detect the position that they are in. Proximity sense, it could be proximity sensors, it could be gyroscopes, it would be sensors to detect the positioning of the arm in the air, its XYZ axes, and so on and so on. There will be tons of sensors working as well. There would be either image sensors to see where, for controllers to see where the arm is actually at, and there will be motors moving. We have seen small robotic arms which moves, which doesn't need a lot of force for the work they are doing. So let's say a robot arm that is used to paint the vehicle or to weld the vehicle, they don't need a lot of force. So in that case, we can use motors. We can use motors to move the arm. But if you've seen, there are some arms that would lift the chassis of the vehicle by itself, or a huge component of the vehicle by itself. So that means strength is needed. That strength would be given by hydrodynamics, and for that, to control it, pumps and valves can be used, right? Again, there are switches and relays. We talked about again switches for lights, plugs. Then relays would be coming into everything, where there are a huge consumption of electricity as well. So autonomous driving vehicle, again, like having all the sensors, it would have all the actuators that we can think of. A car would have, or it would have a motor, right? It would have pumps either to handle the brakes, or from handling the brakes to wipers, to things like that. It would have it. Then if it has valves, it would have pumps, so on and so on. There will be autonomous driving vehicle is a good example of a IoT device which have most of the sensors and actuators within it. Because let's say that if you have seen videos of Tesla vehicles driving by itself, you can see when it comes to a turn or need to change lanes, it would turn the wheel by itself. That means there is a motor working to give that outcome. So that means, again, actuators are in actions. If when it rains, when the car detects from moisture sensors that it is raining, When the wipers come up automatically, that means the moisture sensor senses the rain, sends the data to the processing unit of the car. The processing unit then activates the motors where the wipers would work. You can see the simple flow from sensor giving out data, and the car processing the data, and then the command going into the actuator. So then we of course we have to talk about this one for actuator, smart locks, right? This is one, if you check projects of IoT, this is one of the most used projects, right? The sensor would detect the fingerprint, it will be processed, checked with the database, and if the fingerprint matches, then the lock will come out, so the door can be opened, right? For that, of course, there will be the lock itself is a actuator. Again, a very good example for using of actuators. Then, so we talked about sensors, we talked about actuators. Now we are talking about embedded systems, right? Embedded systems. So let's look at what embedded system definition would be. IoT embedded systems are small computing devices that are designed to be integrated into IoT systems. These systems are used to collect data from sensors, process the data, and control the actions of the actuators. So this is the processing unit. So we said first there will be sensors in a IoT, right? In a IoT device, right? Let me try to differentiate what I'm trying to explain in this portion and this portion, right? Introduction to basic IoT architecture means all these 4 points create IoT itself, Internet of Things. Create a IoT system where thousands of components, thousands of sensors, thousands of actuators, thousands of processing units, it's interacting with thousands of people, creating this whole IoT infrastructure. The entire IoT infrastructure would have these 4 layers. When designing a IoT solution with, let's say, 1000 sensors, 300 actuators, 5 control units, and ability to get that information remotely to other locations, right? That means a huge number of processing power is needed, huge number of interaction between humans and the IoT systems are needed, huge number of sensor physical devices are needed, and a large network is needed. When creating such a huge IoT system, by definition, IoT is a huge system. When creating a IoT system, right? When creating like connecting thousands of weather detecting services and controlling building a smart city, we need to create these 4 layers. When building the architecture, we have to perform these we need to create these 4 layers separately and connect them together to build the IoT system. Here we are talking about making either a IoT device or a simple embedded IoT system. here we are talking about when, right, the components needed to create a IoT device or a small embedded IoT system, right? Of course, multiple. Now think about, right? As we talked about, we can take the Roomba. These 4 components are there in the Roomba. If you take the fridge, these 4 components are there. If you take a robotic arm, these 4 components are there. So the IoT device is made, right? So in a factory there will be 1,000 robotic arms working together. That makes an IoT system. That IoT system should have these 4 layers working in conjunction to create a full IoT architecture, right? That architecture itself would have these components, but when designing an IoT system, right, the robotic one, a single robotic arm would have these 4 components. So let's talk about embedded systems. So we know now the sensors give a input. The sensors gives the input to us, right? And that input data will be processed and analyzed, and a command will be given to the actuators to work. That so an embedded system is a unit where there will be processing power mainly. There would be a processor needed, RAM and other components would be there, right? So it will take in the data from the sensor, it will process it, right? If a camera, the image data will be coming in, and that data will need to get processed. A proximity sensor would basically, right, let's say a small IR sensor, it will detect the strength of the IR reflection, right? That means that data should be processed into numbers where we can figure out the distance between the 2 objects. If you take let's go to the examples again, right? If you take a contact sensor, right, these will be connected through a small magnet, and when the decoupling occurs, the strength of the difference of that magnetic field should be calculated to see if the door is open or not. If you take a smart lock, right, you have to read the fingerprint, then you have to see the fingerprint data from a storage, from a set of data which is already stored inside the device, and it should be compared between the stored pictures and the image that was generated by the fingerprint sensor. So all these processing takes place in the embedded system. By now I think you may have heard of Arduino and Raspberry Pi. Those are the main 2 embedded systems that gives the processing ability and the memory, the processing ability, and the ability to connect sensors and actuators to perform the tasks that are needed from a IoT device, right? So now you have when I say Raspberry Pi, now you have an idea what kind of a component we are talking about. So each device inside would have a component, right? So if you take this fridge itself, if the smart fridge has a screen, that means there should be there's a graphical user interface there, So to give that graphical user interface, there should be either a VGA or some kind of processing unit to process that data. If you take a vacuum, this vacuum cleaner, there should be a small processor, at least a small processor inside, to read the data which is given out from the proximity sensor, and then to give commands, right? Process that data, understand the distance between the object and the vacuum, and to give a command for the actuators to do the necessary adjustments to turn into another side, right? So the processing power and those things comes from these embedded devices, right? By now we talked about these examples again and again and again. I don't think I need to tell you that each example I gave would need the ability to process data, right? And for that ability to process that data, embedded systems are used. If you take a device like the Roomba or the robotic arm or the smart fridge or a smart lock or so on and so on, we can build it in a way that all the processing power needed to do its functions could be built in. If you take an autonomous vehicle, if you take a Tesla car or some example like that, the processing power is there. It doesn't need to connect to the internet. It can detect its surroundings, process that data, and travel by itself. We have seen self-parking cars, same scenario. Doesn't need to connect to the internet, doesn't need to connect to the cloud for taking in processing power, to have shared services from the cloud. It has the capability to function by itself. That processing power, that makes an embedded system. The autonomous vehicle, when not connected to the internet itself, it is an embedded system where sensors, actuators, and processing power, the embedded system, would work by itself, right? Then let's go to the fourth component, and again one of the most important components of IoT, right? We talked about in the definition itself, the importance comes from the definition itself. It talks about physical objects, sensors, actuators, right? And they are network of physical objects. So then this component is also very important when coming into creating a IoT device. There should be a network component to it, right? When those sensors, actuators are networked with a processing device, right? When they are networked together, they will create an IoT device. And when that IoT device is directly connected to the internet, right, it will become a part of a IoT system or part of the internet itself, Internet of Things itself, right? Let's quickly go to the definition of IoT networks. IoT network devices are used to connect IoT components, right, the above three components together and to get and to the internet. Okay, so there are two components to it. Connecting, there are two features to it. Network is there to connect sensors, actuators, and embedded systems together to make the IoT device, right? And to connect that IoT device to the internet. Examples of IoT networking options include Wi-Fi, Bluetooth. These two, of course, familiar with. Then Zigbee, Z-Wave. We have LoRa WAN. These things, Zigbee, Z-Wave. I think this LoRa WAN, NB, IoT, Sigfox. These set of connections, right? We will be talking about it in the future. We will be first talking about sensors, actuators, and embedded systems. Then we will go to the network itself. These, especially Zigbee and Z-Wave, is used mostly in IoT devices. There's a reason for using those communication networks or those protocols in networking IoT devices. We will talk about it in the future, right? These last five examples, Zigbee, Z-Wave, LoRa LAN, or NB IoT, or Sigfox, are networking protocols specifically built for IoT systems. These are specifically built for IoT systems. Wi-Fi or Bluetooth or any other protocols, methods of connecting devices through networking is well known. But these other Zigbee, Z-Wave, those things, those protocols are specifically there for networking IoT components, right? There's a reason for it, right? Because because some IoT devices, the main reason is that some IoT devices does not consume a lot of electricity and power due to their need or their application. So using Wi-Fi or Bluetooth is not an option for communication, right? So we will talk about this in future lessons when we are talking about specifically about networking, right? And we will talk about the properties of Zigbee, Z-Wave, and others, right? The main two are Zigbee and Z-Wave. Why we choose these specialized networking systems, right? Is it the amount of data that is being transferred? Is it the power consumption? Is it the ability to the ability to handle multiple number of devices in a single mesh or a single network of IoT devices? So there are these topologies, or no, these network protocols have different properties. When we select these networks depending on those properties, we will go through these things one by one in the future itself. When coming back to Wi-Fi and Bluetooth, it is obvious, and we know what is Wi-Fi and Bluetooth. If you take Wi-Fi connectivity itself, is mainly used to connect to the internet. Comparatively to Bluetooth or any other or cellular connectivity, Wi-Fi is a more energy efficient comparatively. It has the capability of carrying large amount of data, right? And it has the ability to handle a large number of large number of devices as well. But compared to Zigbee or Z-Wave, the power consumption is high on Wi-Fi as well. So these things we can talk about in future lessons. But again, we will go to, so before going into the next slide, let's talk about how network works for the above components. So the sensors, actuators and embedded systems should be connected together. The processing power, the sensors and the actuators should be connected together. They can be networked through wires itself. They can be networked through wireless means as well. In that perspective, right, because the sensors themselves could be in different locations, right? If the distance is great, then a wire will putting a wire between these the processing unit and the sensor, then another wire from the processing unit to the actuator. If the distance is, let's say, 30 meters from one end to another end, that it is easier to have a wireless connectivity. That's when Z-Wave or Zigbee comes into play, right? And one of the things that again this embedded system or this device should be connected to the internet. For that, of course, Wi-Fi is a great option, right? Let's go to an example above and check. Okay, if you take the smart fridge or the Roomba, right? We talked about there will be multiple sensors inside this fridge, and again in the Roomba there will be sensors and there will be actuators, then there will be processing power. So all these things are connected together. Most of the time it would be a wired connection, right? They are networked together. They are not located in the same motherboard. They will be connected in different locations inside the device itself. That means they have to be networked through wires or either a very small wireless network, which the range of it, the range of the wireless network could be less, the power consumption could be less, and the amount of data from point to point that is needed to be transferred would be less, right? From a single sensor to the processor, the amount of data that is needed to be transferred is not like transferring a huge chunk of data. So that particular networking will happen inside the IoT device itself, but the smart fridge is then connected to the internet. When connected to the internet, we can see it takes either music files or it take cooking example videos from YouTube. That means a large amount of data should be transferred between the internet and the fridge itself. Then, rather than using IoT centric networking options, it will be using Wi-Fi, because even the fridge would be located in one location, the Wi-Fi router would be located in another location. Wiring would be a problem if there is if it is not built for wiring, if the house is not built for wiring and the fridge was taken in new, wireless communication would be the main option to be taken, right? So there are, when talking about network, the network comes in different levels, right? The smoke detectors talking to control units, and the control units talking to fire extinguishing platforms, right? This itself could be done without connecting to the internet and in an internal network. Then again, processing of that data, when the smoke comes in, the sensor detects this, then those data from the sensor is sent into the processing unit inside the smart smoke detector, and the smart smoke detector would detect whether it is smoke from a fire, or smoke from a cooking incident, or smoke from a cigarette, something like that. And that particular data can be sent into the control unit. So there are small bunch of networks which are working together. So inside the smart device, right, the networking would be here. The smart smoke detector between the sensor and the small processing unit would be wired, and passing that data into the main control units, it would be wireless, or it would be from a cabling solution. It would use Wi-Fi itself to communicate these things, right? So from data to the processing unit, it's just a single sensor sending out data. But if you take multiple number of let's say a 50-story building has, let's say, at least 500 smoke detectors from top floor to the basement, and that data going into the control system would need a large scale network that can handle the amount of data which is being pushed to the control system, right? That means it would have either wireless or wired connections. There would be layers of networks with switches and APs handling that data, and feeding it to a processing system, and that data would be also passed into the internet itself. So that means the networks that we know of, right, passing that data would be going through APs and core switches and so on, or either through a virtual cloud network. It would be passing the data. Those are the basic networking that builds the internet itself. But in between devices, communication in between devices or internally inside the devices would be a different story in IoT, and we will be looking into that particular part going into the future, right? So again, introduction to basic components. We talked about sensors will be collecting data and inputting data into the embedded system. The embedded system will be processing that data and sending commands to the actuators to do the needful, right? And all these sensors, actuators and embedded systems are connected through networking, right? Networking again can be used to connect that these embedded system, actuator, sensors together forms a IoT device, and that IoT device, right, that IoT device would be connected to the internet to make it a internet of things, part of internet of things. There will be again a network working to build it, right? So we talked about application layer. Again, I will give you the difference between, right? We talked about Zigbee, Z-Wave, Sigfox, right? And LoRa WAN or NB IoT networks, right? These are different protocols, right? We talk about them here when talking about networking internal devices, right? But when you go to the architecture itself, you can see the nodes change from Wi-Fi, Bluetooth. These are networking protocols that could handle large amount of data. Cellular and satellite connectivity, right? So these satellite connectivity protocols, or cellular, Bluetooth and Wi-Fi, are things that are used when creating large networks and connecting to the internet itself, right? You can see that network layer is different from the network layer inside or when we talk about components inside the device itself, the networking of IoT devices in an internal system, right? Then it goes to a different set of, right? The cellular data would be taken off, the satellite data would be taken off, it will be replaced by other protocols which consumes lesser energy. I will talk about why we need less energy, why we need less radio frequency, or the distance between these devices matter when selecting the network we are going to use. These things in future lectures, right? So these are the four components of basic IoT. These are the basic IoT components when building a system, right? Let's finish this PPT with the following, right? This following statement: all these components work together to form an IoT system, right? Sensors collect data from the environment, which is then processed and analyzed by an embedded system. The result of this analysis are then used to control the actions of IoT actuators, which can be physical devices or systems. Network devices are used to connect all these components together, right? And to the internet. Sensors, actuators, and embedded systems to connect all those devices together, right? All those devices or systems together, network will be used, and it will be used to connect to the internet, allowing for remote monitoring and control of the IoT system, right? So this is what the above, applying those above four components, they will work together to create a IoT system. And the networking part of it, which is a very important part of it, will network everything together to build, from creating IoT, Internet of Things, to individual intranets and individual IoT devices, right? This small example would teach us right, or give an example of how these components work, or the architecture of it works, right? So we have an embedded system. The embedded system would have IoT devices, right? Then it will have IoT gateways, right? Most of the time, if you take embedded systems, the network component and the processing component comes in one motherboard itself, right? If you have seen Raspberry Pi, or if you have seen Arduino, this is visible to you. There will be the network component and the processing component will be together in one motherboard itself, right? That would create an embedded system, right? This processing device and this networking component will be connected to sensors and actuators, right? Which it will create a total embedded system, right? And that system, right, we will, end of this lesson, we will learn how to make an embedded system, right? By the end of this, you will be able to see a problem, recognize a IoT solution, build an embedded system to the problem, to build an embedded IoT system for the problem, then that would be the main goal of this lesson, right? The rest of the part would be networking of all those embedded systems together, right? So we will be, if we are talking about right, we will be talking about build, let's say, a smart lock or a robot arm. We will be talking about the networking inside the robot arm, the processing inside the robot arm, the sensors and the actuators in the robot arm. Or the smart lock, if the same thing, the processing power, the sensors and the actuators, and how they are networked together or connected together, we will be talking about it, right? But if you take a building, all those security locks should be connected together through a network. And if it is a manufacturing plant, all those robots arms should be connected together. That means there should be a network going on. That network would be connected, let's say there are 1,000 doors, and every door has a smart lock, and the network of those smart locks would be connected to the cloud, and they will be processing data and giving it to the application, where, let's say, the security guard who's in the first floor or in the lobby could see who is opening the door at which time. So that is Internet of Things, right? Internet of Things is basically whatever that we can automate will be automated and connected to the internet, right? Connected to the internet. So this will be the main part of it, right? We learned about the basic architecture. It would have these layers, right? Now you can see the layers, the device component, IoT gateways and everything built in the embedded system. Then we talked about the network layer, right, where all these devices are connected together and will share data between each other to work in unison, to work to work together. Then again, the cloud and the applications would be there. The application layer is, of course, there for humans to interact with the IoT system. The cloud layer is there for shared resources of processing power, storage, and so on, right? So this makes Internet of Things. So by the end of this, by now you will understand, or you will be able to recognize a IoT device, and you will be able to understand how IoT devices interact with each other to give an output. You will then recognize, when building an entire IoT system, what is the basic components of the architecture. Then you will now understand, now you have the understanding of, when building a IoT device, when building a IoT embedded device, what are the components needed to build that embedded IoT device. Now, as we have looked into the architecture of IoT, and we have looked into the components of IoT, we will move to the next chapter. The next chapter in IoT, or Internet of Things, consists of the following content. It is introduction to sensors, introduction to actuators, introduction to network, introduction to embedded systems. Basically, what we are going to learn through this is a small introduction to what are the sensors, actuators and networks, and also embedded systems available in IoT when designing IoT, when designing a hardware component, right? So we talked about embedded IoT device, right? We in that, right, let's take a small let's say we take a small refreshment out of it, right? So we talked about So we talked about IoT embedded device. IoT embedded device would have a sensor. It would have a sensor. Maybe it would have couple of sensors. It would have a processing unit, and the processing unit would control a set of actuators, right? These sensors will be connected to the processing unit, and the processing unit will be connected to the actuator. So these things will be networked. This creates a single embedded IoT device, right? Then again, there would be another one just with sensors, right? Collecting data and giving it to a processing unit, right? This could be also a IoT device, and there would be maybe one sensor, right? And that would give instructions set by set to, let's say, 3 actuators. The processing unit will give for 3. So these again, it's a embedded IoT device. So there are set of IoT devices. So the components, we talked about the basic components of IoT devices make each of these, right? These basic IoT embedded devices. Inside those embedded IoT devices, you can find a small network between the sensors, embedded system or the processing unit, and the actuators. And when those devices are connected to each other and work in unison, when this sensor takes its data to the processing unit, then the processing unit sends it to the actuators and to this device itself to compare that particular data with the sensors they detect, right? It becomes a small IoT system, right? This becomes a single IoT embedded device. This is a single IoT embedded device, right? And this is a single IoT embedded device. And we can categorize all this as a single IoT embedded system, right? We can just round these things off. These 3 IoT devices working together, or they can be more. They can be 3, 10, 20, 100, 1,000. It could be, right? So if you take those set of IoT devices, right, which are network together, creating a small IoT system, right? Then if we have another set of systems like that, network together, right, sorry about that, all around the world, right? Let's say one sensor would detect temperatures in one area and send it to another complete different area around the world. That would make, right, this IoT system would make connection with another IoT system. This IoT network would create with another one. So basically what would happen is this whole network would be connected like this to the system, right? And these devices can talk to each other like this. Similarly, now this working around the world, right, would create its own IoT networks, right? All these IoT systems create. So you can see the basic components. We talked about sensors, actuators, embedded systems, and networking would make a small the basics of it, the basic components will work together to make a embedded IoT device. That IoT device can be can be networked between other IoT embedded devices to make a system of IoT devices. When that system of IoT devices is networked between another set of IoT devices around the world, it creates Internet of Things, right? When we talked about the architecture, we talked about the perception layer. The perception layer would be the embedded IoT device, right? We talked about a network layer. Network layer differs from networking inside the IoT embedded device to networking between each embedded IoT device, creating IoT system, and the connection between in every IoT device through the internet would be the network layer for would be the different network layers applied in creating in the IoT architecture. Then the cloud and the application. Of course, when these systems, right, when these systems are connected to the internet, that means they can be directly connected to the cloud, right? And the data could be shared either way. Data could be stored, cloud resource can be allocated to do any processing or anything, so that data would be going either way, right? And that data could be, again, because this is the internet itself, right, that data would go to other systems, right? Those data would flow down from the cloud to other IoT systems, right? Those IoT systems can talk to each other as well, right? Thus making the internet talking to each other and so on. Then again, that would then again go to embedded systems, right? Like a total, right? These embedded systems would have sensors, actuators, and small processing units, right, networked, working together inside, right? And this is how, right, so we have another system like this, and we have we have connectivity between these embedded devices, right? And that connectivity would directly then be connected to other systems as well. So this is the cloud itself, right? These are so you can see a sensor that takes in data from one end, right? Let's say a sensor that takes data from this end, right, could pass the data through, right, the embedded from the embedded device to the IoT network or intranet. Then that data would go through to the internet, right, and it will go through the cloud, get processed here. Then again that data would be traveling through the network of IoT devices or the internet itself to a different device, all maybe in a different location in the world. And this, let's say this is an actuator, that actuator could function by the data which was fed by the sensor here. This is Internet of Things. When we talk about the basics of the architecture to build this whole network from this corner to that corner. To build that whole network, we were talking about that is the architecture to build the entire IoT, Internet of Things, where every device is talking to each other everywhere around the world through the internet. When we talk about components that builds a IoT, we are talking about, right? We are talking about this to build the components that is needed to build a embedded IoT device, right? Everything starts from that particular point, right? So right now what we are trying to understand, right now what we are trying to look at is the components that is needed to build a IoT embedded device, or the very edge node of the IoT network. Networking these sensors or these embedded devices, right? We will learn the embedded device. It is built by these 4 components. When those 4 components are put together, we will get an embedded or IoT device. That could be from a smart smoke detector, or a smart watch, health monitoring, weather monitoring device. It could be a temperature monitoring device, a smart light. We talked about smart cameras for surveillance, and so on and so on and so on. It could be anything, right? Now let's take an introduction to sensors, or let's take what examples of sensors that are available for us when building a IoT, right? So basic IoT components, we took an introduction, and we are going to talk about sensors. Now here the first point that you have to understand is we are going to look at several examples of sensors. These are not all the sensors that are available for building a IoT network, or building IoT, right? There are many types of sensors beyond the sensors that we are going to see here as examples. Depending on the requirement, it is up to the engineer who's building, or the architect who's creating the IoT system, to understand the requirement and see what is the proper sensor. So we will go to device or sensor, right? So this is these components are there on the perception layer, sensors. Internet of Things, IoT sensors are physical devices that collect data from the environment and transmit to other devices, systems over the network. So we talked about when talking about taking an introduction about the components, we talked about sensors and what are they. So let's look at, so the main thing that it collects data from the environment, right, and transmits it to either an embedded device or through the internet to the cloud itself to process, right? Again, in this lesson, or in this this course, we will be focusing from now on to the main part of IoT, which is the perception layer and the network layer, and we will be focusing on how to build a embedded IoT device. That will be our main focus, right? When you make a whole system out of it, then there will be cloud and application layers to dealt with. But here in this course, we will be concentrating on how to make the perception layer, or to create a embedded IoT device, right? So first example of sensors is temperature sensor. Of course, as it says, it is there to measure the temperature. So it could be the temperature of the environment that sensor is located in. So we use it in different industrial processes, right? If you again, we talked about examples of the same IoT device used in different applications, right? We talked about that. We talked about how the weather data that is being used in different industries. So similarly, temperature data we talked about using for air conditioning or heating when it is winter or not. But again, we can think of other applications where industrial needs are there. For example, production of electricity. If you take either a nuclear power plant, or if you take a thermal geothermal, or again the coal using thermal using coal, any thermal power plant would need to know the temperatures inside their machines mainly for efficiency and safety reasons. So for that we can use temperature sensors, right? Then we have the humidity sensor. Again, humidity sensor would detect the amount of moisture in the air itself, right? I put those two examples together because the sensor that I have given as an example, the sensor DHT11 or DHT11, is a sensor that has both these readings, right? It has the temperature as well as the humidity levels there. So the basic application for this would be when coming into weather monitoring, we can see the temperature outside and the humidity. So both of them are available in one sensor unit, right? But when coming into sensors, before going into other examples, I'm going to talk about the characteristics of sensors. What are different types of sensors that we can find in the market itself? So basically, another point to keep in your mind, right? We will talk about this in future lectures as well, when we are trying to create a embedded IoT system. But now when we say sensors, right, when you say temperature sensors, I told you that there are different kinds of applications. If you want to sensor the temperature inside a room, we can use a sensor like this, right? We can check the humidity and the temperature. But what if we have to measure the temperature inside, let's say extreme temperatures? For example, if somebody, there are research centers in North and South Pole. If they want to measure the temperature outside, it would be around -40 and more. So what kind of a sensor it should be? Then when we talk about temperatures inside car engines, or temperature inside thermal electric production, or inside machines, if you take a nuclear thermal electricity production, the steam generated and the heat generated is very high. So the sensors should be much tougher and much able to detect very high temperatures inside those electricity producing machines to give an accurate reading. So what does that mean? So when selecting sensors, we are talking about again temperature sensors and humidity sensors. Let's focus on temperature sensors as an example, right? So when we are talking about temperature sensors, an example of that would be DHT11. But if you do a primary search on the internet, you will find multiple number of sensors. So you will find sensors like TMP36, right? And it is a very small sensor, right, to measure the temperatures, right? And it doesn't have other processing units, so it should be directly connected to an embedded system to process that data. So there will be, when checking what is the sensor that you need to select to your IoT project, depending on the requirement, the size of the sensor itself would be very important. If you have if you are going to measure the temperatures outside by a unit, that unit, if it is okay for that unit to be big and robust for all weather conditions, right, from rain, sunlight and so on. But if you have something like if you want to measure the temperature of the engine of a vehicle, a petrol engine or diesel engine, you may need much more smaller in size sensors, because you need to fit it into a very small area, because the engine bay of a vehicle does not have that much space to spare. So there's a space requirement when creating a IoT device. That is something that we must consider. Then of course the temperature range, that statistic is also given, right? The temperature range, so that this sensor could actually sensor from -40 degrees Celsius to 150 degrees Celsius. That means when we see a problem and when we see that we want to use temperature sensors to measure the temperature of a certain object or a certain space, we have to check whether the temperature that we want to measure is equal to the temperature that the sensor can measure itself, the maximum and the minimum. If you think we are like, for this, measuring temperatures in our normal environment when checking the weather, this range is more than enough. But checking the let's say checking the temperature of a kettle, a smart, you decided to build a smart kettle or a smart thermal cup, we are going to measure the temperature. Again, this number would be more than enough, because water normally boils at 100 degrees. So anything more than 100 degrees is not required for those measurements. But if you are going to measure the furnaces of a metal manufacturing company, will this sensor be enough? It won't. So then there's the point of requirement as well, right? Then we have the output ranges. These are specifications that are needed to be discussed. We will discuss these things separately, to take when you deep dive into the sensor itself to find what exactly the properties of the sensor. You will see other documentation as well, which is needed to make your assumptions, right? So the output range is given, right? Then there is a statement given by the manufacturer that accuracy decreases after 125 degrees as well. So if we are going to if we need something with a better accuracy during that more than 125 degrees, this is not a good option as well. So they have given the power supply and those things of it. So normally when you are going to select a sensor, you will get a data sheet, you will get a spec sheet saying that these are the temperatures that can be measured, these are the data that you will be taking. Let this part, right, this part is how to select a sensor. This is a little bit a deep dive into how to select sensors and how to select sensors according to the requirement of things. So uh, though, like when we say okay, temperature sensors, there are different types of temperature sensors. So we talked about so we were talking about TMP36 sensor, right? If you type that in, right, you can type it on Google and you will get all the information needed. For example, right, this information was taken from Adafruit. So normally this is a renowned site for the IoT development and sensors information and things like that, right? And in this you will see that they are talking about the sensor and they are giving a small explanation on the sensor as well as what are these pins do. So when you are building a IoT device, you have to do a small dive into what are the outputs that it's going to give. Now for example, this one, it's going to give out raw data, and it's so the analog voltage output means the temperature is going to come out uh, as a different difference in voltage. Also it would be like analog. So this is the part of data that is needed to be processed in the embedded system itself. So all the data we were talking about in the slide is given here, as well as how to measure temperature. So this information including the equations or things like that are given. So this is a, so then if we want to deep dive more into it, right, we want to deep dive into the roots of it, there is always the data sheet is available for anybody to use. So you can see the data sheet, right? On the data sheet there will be all the pointers, including right, accuracy of it. They talk about the accuracy, and each they will show the tests that are being carried out and how the measurements would behave, right? So on and so on. Then there will be the structure, the internal structure of the device, the sensor itself, right? There will be a full length deep dive article and how the measurements are taken and output is given, and even what are the logic gates that are being used. So if needed, right, these can be referred to build a much better system, or we can tweak with the information which is given here to make our own custom device. So the main point that is needed to be identified, right, that is needed to be identified, there will be a set of sensors for the same purpose, right? There will be a set of sensors for the same purpose. So for example, let's try to see temperature sensors. Now, for let's say for temperature sensors which is compatible with Arduino for now, right? So when you have a list like that, right, you will see that in this picture itself there are different types of sensors available, right? You can see that there are different types of sensors available, and these are projects that are being carried out. We will look into those, we will slowly move after looking about sensors into this, right? So all these sensors are there to measure the temperature, right? But all these sensors would work in different ways. So we have the DHT11, this is the first example, right? And in that you can see what are the ranges. So temperature range is from 0 to 50 degrees Celsius. So in winter we can't use this for any using to measure temperatures during winter time if it goes to minus. See, now you can see the limit. So we have to look at the limitations. DT, so DHT 22 would have a much better temperature range. So if you are going to make a temperature measuring device to see the atmospheric temperature, this is much better than the above one, right? So there are other sensors would have different ranges, similarly like that, right? So this is a small deep dive, right? This is a small deep dive if into how to select temperatures, right? If in this section of the lecture I would be going through what are the sensors, right? But it would be temperature, it would be humidity, or it would be light, or so on and so on. But when you take when you understand, okay, this is the problem and I would need a proximity sensor, there will be a set of proximity sensors in the market with different characteristics. So you should be able to identify the properties of those proximity sensors, right? If for example communication protocol, you want to check whether the communication protocol is okay with your embedded system, then you have to check the power supply, or like, okay, 5-watt power supply, this can be given through the Arduino itself, or otherwise you have to have a separate power supply for this. Then you should see the characteristics, what are the ranges that it has, like here the temperature range, and so on and so on, right? Of course the documentation will be given for each and every device by the manufacturer themselves, right? So you see, now when we talk about when you talk about temperature sensors, see how many are there. So here itself there are 9 products with different characteristics, right? So we have to be able to go through the properties of those each sensors and see which sensor work for our requirement, which sensor works with our needs and the rest of the equipment that we are going to use, right? Now this I particularly checked for Arduino. Now if you are going to use Raspberry Pi, you have to make sure that Raspberry Pi is compatible with these devices. If not, then again you have to change. So these things you have to check. So this is we are steering a little bit out from the lecture itself, but if you are to build an embedded device, right, if you are to build an IoT device, in that IoT device if there is a sensor, the first thing you must do is first recognize what is the sensor you need. Second, you must recognize is then you must check for the sensors in the market. Then you must see the sensor is compatible with the communication protocols, with the power supply, with the embedded device that you are using for this IoT project. Then you must also see, when you say, okay, when we recognize we want to measure the temperature, then we must see what are the ranges that the sensor itself covers, and see what is the errors that will be given, right, when approximately measuring these things, right? So for example, you can see here it's a 2-degree difference. It won't be much, but if you take a boiling kettle, this would be 1 degree is enough to change everything. So again, this sensor gives a much more sensitive reading, much more accurate reading with a greater range. So like that, we have to check those property as well. So this applies not only to temperature sensors, for each and every sensor that we are going to give as examples in this lecture, plus other other sensors. Again, this is applied to actuators as well, right? So I just teared out from the main point we are talking about on the lecture itself, just to say that, right, these examples that I am giving in this lecture is not the only options out there, right? Come back to the slides again. So we have the so for examples, right, we have different brands, different products of temperature sensors. TMP36, we looked at it, and we saw how to look at how to find the information through the internet, right? How to find the compatibility with the embedded systems, what are compatible and what are not. Then we check the ranges and the properties of each sensors to see, to find out which one is okay with the requirements we have, the requirements the engineer have to build, right? Then we have the PT100 sensor, right? It has a more vast range. It goes up to 280 degrees Celsius. That is more than the TMP36. So if the requirements are higher than 150, we can use this one. There's the HTS221 temperature. This product will be this product's range would be similar to TMP36. Then again, we have then another product. It is SHT30D, which let's see, it can also, so it has the ability to check the humidity from 0 to 100 range, and we have temperature from -40 to 25 degrees. So there are different products. So from all and all, what I'm trying to say here is, if you are an IoT developer, right, it is not a requirement for you to memorize every single product that is on the market, every single sensor. Like when you say a temperature sensor, there will be multiple sets of temperature sensors available in the market, right? These sensors are mostly what we are talking about. These sensors for humidity and temperature, these are basic sensors. When coming to industrial applications, where over 1000 degrees of Celsius needed to be measured, these sensors cannot be even used. So when we are building IoT devices, what I'm trying to say is, we should know what type of a sensor is needed to resolve the problem. We don't need to know the exact name of the product, because that could be searched, that part should be searched and researched by the engineer who's designing the IoT system. While researching, you have to see about the power, the size of it, the range of it, what can it measure and what cannot it measure, how much the error rate is, how much what about the power supply, so on and so on and so on, right? So it is completely up to you as a IoT developer to find the correct product when selecting the sensor, right? So again, when we talk about sensors, there are multiple number of sensors out there. Temperature sensors, humidity sensors are two examples, right? And then when you see the problem, let's say you want to control or automate the control of temperature inside the office building. You now use so how to automate it is the problem. So the main thing will be you have to measure the temperature. How to measure the temperature? Then you have to have an IoT device. To build that IoT device to measure the temperature, you should have a temperature sensor. And what that temperature sensor should contain, the range of it, the error rate of it, and everything, what would be the best product is up to you to select from each device that is in the market itself. If you are going to use Arduino for building these temperature measuring IoT devices, then you should see what sensor would so Arduino is an embedded system, so what sensor would be compatible with that particular embedded system, right? So these things you should check by yourself. So if you are going to very much deep dive into IoT sensors and how the insides of them are made, to the electronic parts of it for logic gates and those things, you saw that there is a data sheet for each product that would give those information as well. So you can do different tweaks and things whenever you want to make your own custom product, right? So this is a little bit going away from what we were talking from the examples that I'm going to give, but I actually added this part very late because I was thinking, when I say temperature when I say okay, a temperature sensor, and a temperature sensor looks like this, the main thing I want to say is it's not a constant. The products could change. There will be different kind of temperature sensors out there, so that detecting humidity, it's the same scenario. There will be several products will be out there. Then you should, when selecting the product you want, right, the product that matches your project, right, it's up to you to again search on internet, right? You can see sometimes when doing a project you would even need to see the price ranges, right? So everything you have to figure out by going through the product, price of the product, the range that it covers, the amount of electricity it consumes, the compatibility with the embedded system, so on and so forth, right? So those things should be studied when selecting the correct embedded device, right? So again, I'm just giving examples in this for other sensors as well, but regardless, right, the common term for a sensor would be temperature sensor. There will be different kinds of temperature sensors or different kind of products available for measuring temperature in the market, which would act as a temperature sensor. Humidity sensor, same scenario. Humidity sensor is the common term. There will be different products available. So so those are the things that I wanted to highlight. So I'm going to now go through a set of other examples of sensors, right? And in each and every scenario, please remember that what is being shown here is a general term. Now here in the third example, it is the pressure sensor. But then again, the pressure sensor is not a constant. There are different types of pressure sensors available with different which can be used for different applications, for example, the pressure inside a tube which carries air is different from a pressure inside a tube which carries water, and it is completely different from a pressure inside a tube which carries oil. So these things, for measuring these things, the general sensor that we talk about is a pressure sensor, right? So that is what we are That is the point that you should remember when we are talking about sensors, right? The general term would be a pressure sensor. When we see the problem, if somebody comes to you and say, okay, we want to automate this part, right? We are pumping petrol from this location to another location through an underground tube. We want to check the pressure of when the oil is traveling through that tube. So the first thing that you should come to mind, it should be a pressure sensor. But then you should be able, when designing a thing, you should be able to understand that we are talking about a liquid, and we are not talking about air. So measuring gases, the pressure of gases, and measuring the pressure of liquid is there's a difference. So, and then again, it's not water, it's a much more thicker, dense liquid. So how am I going to, what will be the proper product, or what will be the types of sensors that I can use to measure that, right? Again, mostly when coming into IoT small scale projects, right, you will be able to freely find a lot of products, right? What I gave is an industrial application, but there will be general applications in your home or a building, something like that. So in those, rather than going to extreme measures, you will find many pressure sensors out there, right? So one of the pressure sensors, so again, pressure sensors measure the pressure of liquid and gases, and are used in a variety of applications, including process control, automotive, and aerospace. Yes, pressure sensors would be, I think, when coming into pressure sensors, the applications would be more towards industrial rather than towards domestic. So there will be a lot of industrial applications. So pressure sensors could be from several examples: AMS 5915 dash 0100 dash D, or MPS 20 N 00400 40D. So there are different MPX 5010. So these are different sensors that are out there, which will measure pressure with different potential, with different characteristics. So the general understanding is there are sensors to measure pressure, gas or liquid. It is up to the engineer to find out the specifications, to find the range, find the either it's a liquid or a gas, and then select the correct pressure sensor. Give an example. Another example would be, okay, this is also another picture of a pressure sensor, right? These sensors are used to measure pressure according to it could be either liquids, oils, or it could be non-corrosive water, then again to gas, right? So these sensors are out there either to compare. And another point, now the pressure sensors can be used, for example, to see water levels. That's an interesting application of pressure sensors. So if you take either A-level physics or I think in O-level as well, let's say A-level physics, you know that when a column of water rises, the pressure at the bottom increases. So there is a direct correlation between pressure at a location and the rise and fall of the liquid itself. So we can actually if you know the size of the container, we can actually determine the amount of liquid that is there on that container from a pressure sensor, right? It can be possible. There are storage units of oil. Oil is stored. There are oil is stored not only in petrol stations and large storing areas. Oil is stored inside vehicles as well, to measure those things, right? There are different kind of liquid materials for either things like paint, right? Chemicals for manufacturing fertilizers or pesticides or whatever. It would be stored inside large containers, making drinks. Either it could be something like Coca-Cola, Pepsi, some things like that, to measure the pressure inside those. From a small bottle to the large container, they mix the product in. Everything would be measured, and assessments that because we know the size of the container, we can even know how much liquid is inside the container without looking through a pressure sensor. So that's another application. Not only when checking the pressure for safety while the liquid is traveling, we can actually use that data to calculate the amount of liquid that is inside a container, right? So there then again, in pressure sensors, there are different kinds of sensors out there in the market. Again, it's up to the engineer. After recognizing it can be measured through the IoT device can be made made using a pressure sensor to understand the requirement, the amount of pascals that is needed to be or that is needed to be measured, or something like that, the amount of pressure that is needed to be measured, and to get a correct sensor, same as the temperature sensor. When coming into motion sensors, these sensors detect motion and are commonly used in security systems. Yes, we talked about it in examples. Smart light systems, I think this you have seen, it's getting very famous in Sri Lanka as well. Smart lighting systems which switch on when a person or entity is moving near to that location. And wearable devices, of course, your smartphone or your smart watch. Actually, when coming into wearables, it would be your smart watch would have motion sensors to detect the steps you are taking, and if you are in a movement or not. Those things can be measured. So for examples for security systems, we talked about it. Motion sensors, we talked about how alarms can be generated through motion sensors near either doors or windows when activated. Smart lighting systems, we talked about smart lights, and of course we have seen this in mainly in houses. When a person moves near to the light or in front of the light will switch on. That means the motion sensor is detecting that there is movement in front of the light or the area that is it being scanned. So again, motion sensors. So seeing a problem, applying the motion sensors, again like the examples above, right? You have to check the compatibility, you have to check the amount of power that it is being used, and of course the effective distance. That is the main property that you must use. Like if you want to cover a radius of, let's say, 5 meters, or if you want to cover a radius of 25 meters, it's a big difference when coming into the sensors itself. So the requirement, the properties, the ability of the sensor must be checked. Again, how it's checked, as I showed you before, you can go into a search engine, right? If you can Google it, you can Google is right after you understand, okay, I need a motion sensor to detect, so I'm going to make a surveillance system, right? A security system for a building. In that security system, I'm going to use motion sensors, right? That will be a component. It will be connected, it will be networked all together to one control base, and that's how I'm going to build my IoT system to that building, right? IoT security system to that building. So then you will see the requirements. For example, the main entrance, I need to cover 6 meters area. For the main entrance, the door is big, there are a couple of doors to enter for that building, so that is needed to be covered. The other areas, I only need to cover 2 meters or 3 meters in front of the door, right? So you look at the requirements, and you then if you Google motion sensors that are available in the market, right, you can select, there will be set of products, you will be presented with a set of products. You will go to its official site and see, or take the data sheet out and see what are the ranges that it can be achieved, what would be the errors, how much the strength would be of the sensor itself, so on and so forth. Then select the correct sensor, right? One of this motion sensor, then it is HC-SRO SRSOI passive infrared sensor, that we are the example this in this PPT in this lecture, the example that is given is that sensor. But then again, as I told you, after recognizing the requirement, you should select from the internet. So when we go again, now we can check the other example. The other example is proximity sensors. Proximity sensors, we talked about plenty of the usage of proximity sensors when you talk about especially either the lights or especially the Roomba vacuum. That was the best example. Or the robot arm can use that one, motion sensors and proximity sensors to figure out if the arm is near enough to object when working with it, right? So these are the sensors that can be used. These sensors detect the presence of nearby objects, and these sensors measure the distance between the objects and are used in applications such as robotics. Roomba vacuum comes into our mind again. Automotive industries, smart vehicles, right? We not even smart vehicles, we even normal vehicles today, we have the proximity sensors which gives warning when you get nearby to a vehicle. Industrial equipment and customer electronics, right? So of course, custom electronics, even toys, we have seen that there are proximity sensors in toys where they can go near toy cars can travel towards near a wall or maybe a table and turn around without hitting it. There are toys like that. Those also, and in Arduino projects you may have seen plenty of, especially the example given here is ultrasonic transducer proximity sensor. This one is commonly used for the Arduino projects when showing the ability of a proximity sensor. Again, there's another one, infrared LED based proximity sensor. So both of them would work if it is ultrasonic, right? The ultrasonic, then sound, the wave would travel, hit the object in front of it, comes back to the sensor would absorb that data and determine how far the object is, or if there are object in front or not. IR LED based proximity sensors, it would be the light energy which is bouncing from the object in front of it. put this application into a very uh, big example, what would you get? Radar systems. Radar systems especially for planes and air defense and those things. But if you take then again proximity sensors in cars, vehicles, that is mostly seen in the automotive. If you take the robotics, of course, you have the robotic arm, we talked about it. So when that arm needs to be moved near an object, it should have the ability to sense where it can freely move and where it should stop, or otherwise the product that is being built by the arm itself could get damaged. So those things have to be measured. Again I will repeat what I said before about temperature sensors, proximity sensors. So you can see there are two kinds of proximity sensors as examples here. There will be plenty more products with different values, right? Different ranges. These proximity sensors may have some range, and if you want to see further, it should be much more expensive proximity sensors, right? Things like that. So again, you have to then find the requirement and do the research and find the needed equipment. For example, if you take a proximity sensor, that is used in an Arduino project, the electricity consumption is very less because the range that is being monitored is very less. But if you want to increase the range more and more, the sensors would become larger in size, the amount of electricity consumption becomes more. That means a separate power source must be dedicated as well, right? Things like that will take place. So when again designing you should consider requirement and the then select the sensor you need. If the ultrasonic sensor would not work in such scenarios, you can use the IR LED based proximity sensor. But if using light to find proximity is not a good, it's not working properly, let's say there would be dust particles or things like that interfering with that, then you can use the ultrasonic sensor. So requirements, you have to check the requirements. So these two examples are given because these two are completely different. One is sound, the other one is light, right? There are positives and negatives when choosing what you want. But again, the general topic is proximity sensors. Now you can see that the above one, the motion sensors and proximity sensors, has the ability to check the presence of something in front of it. So that's a common property that is being shared by both of those sensors. But the difference for proximity sensors is they can detect the distance between in the device, the IoT device, and the object itself, right? So the proximity sensors, they have different categories: inductive, capacitive, optical, magnetic. Again, we talked about the contact sensors before as an example. Those contact sensors use magnets. They use magnets to see if they are in contact or not. So this magnetic power actually can be used to see the proximity of things, especially if you want to if you're working in a very close range, very sensitively you need to measure it, right? We are talking about centimeters and millimeters. Magnetic power could be used. Then of course we talked about ultrasonic. Optical would be IR LED based proximity meters. So again, the proximity sensor should be selected according to your need for your project. Then light sensors, of course we talked about smart lights as examples. We talked about light sensors, right, on weather stations, connected to light bulbs in cities, in streets. They will come on when this light sensor detects that the light is low and we have low visibility. So light sensors, these sensors measure the amount of light in the environment and are commonly used in smart lights systems and environmental monitoring systems. So we talked about them extensively on this on this subject matter. We talked about examples, we talked about applications on them as well. Again, when selecting, it is up to you to see the ranges, sensitivity and products as well. Two examples for this product would be GL5528 and MD0222. So those things, again, it's up to you to find out if you are depending on your embedded system and your it depends on your embedded system or your um, actually your requirements. If you are measuring high intensity light, right, for an experiment or something like that, it's a different story from measuring sunlight outside, and so on and so forth. Right, we will pause for this lecture from here. I think we have covered 2 hours. Right, we will in the next lecture session we will try to go through rest of the examples here, right, and we will go to actuators. Then we will discuss a little bit about network layer and the devices we used, and I think in that we can talk about Zigbee, Z-Wave, those things, right, and try to understand why they are in use, why they are needed for IoT devices. We will talk about IoT embedded systems a little bit, and then we will go into embedded system examples, what we can use, what is available in the market today, and how we can use them. Then I think we can cover all the components that is needed to build a embedded IoT device, right? So after covering all the components, then we will move to understanding a little bit about we will talk about networking on IoT devices, right? After we talk about networking, then we will then move to from understanding a problem requirement and how to build a embedded IoT device, how to find the necessary, what are the, to select the necessary sensors, from coding to creating a IoT device. We will look at those examples as well as we move forward. For now, we will pause the lecture from here, right? In the next lecture we will go into other examples for sensors and then actuators, and we will move forward from there. Okay everyone, thank you, have a great day, take care.